Let's take a look at the first example. Please notice that this time we have extra variable in our trinomial, okay? In the second term and third term. This is b. And please notice that b in the third term is raised to the fourth power, and b in the second term is raised to the second power. Anytime you will have exponent in the third term, which is twice of the exponent in the second term, you can forget about these b's for a moment and simply rewrite the expression without b's. So my quadratic trinomial is going to look like this: 9a squared minus 48a plus 64. 9 times 64 is equal 576. Next, I'm supposed to ask myself question, what two numbers multiplied by each other are going to give me 576, and the same numbers added to each other are going to give me negative 48. With the multiplication, it could be kind of difficult, but if it comes to the addition, it could be a little bit easier. We know that minus 24 added to negative 24 is equal negative 48. Let's check what we are going to get from the product of these two numbers. Negative 24 times negative 24 is going to give me 576. So these are the numbers which I'm looking for. Next, I'm supposed to rewrite this expression, but instead of negative 48, I'm supposed to write negative 24s. So I'm going to have 9a squared minus 24a minus 24a plus 64. Next, you're supposed to check what we can factorize in this expression. I have 9 and 24. I have a squared a. From these two terms, I can factorize 3a. Inside of parentheses, I'm going to have 3a minus 8. Let's take a look what we can factorize from these two terms. From these two terms, I can factorize negative 8. And inside of the parentheses, I'm going to have 3a minus 8. Common factor for these two terms is 3a minus 8. Whatever left, we're supposed to write in second pair of parentheses 3a minus 8. Someone can say that this is end of the problem, but this is not solution yet. Remember, at the beginning we forgot about b's. Were I supposed to add them? First, please notice that first term of my quadratic trinomial doesn't contain b. That's why I'm not going to have b in my first terms of the factors. Where I'm going to add b, I'm going to add b for sure to the second term of the factors. Now, please notice that the third term of my quadratic trinomial has b to the fourth. So I'm supposed to write my answer as 3a minus 8b squared and 3a minus 8b squared. Why b squared? Because b squared times b squared is going to give me b to the fourth. And let's check if this is the right solution. 3a times 3a gives me 9a squared. 3a times negative 8b squared is negative 24ab squared. Negative ab squared times 3a gives me negative 24ab squared. Negative 8b squared times negative 8b squared is equal positive 64b to the 4. Now we're supposed to combine the like terms, and I'm going to have 9a squared minus 48ab squared plus 64b to the 4. As you can see, we got exactly the same expression which we had at the beginning. That's why this is the solution to my problem. Let's take a look at the second example. First, we have to factorize the common factor. Common factor for these three terms is 4. Okay, that's why I'm going to write 4 at the front of the parentheses, and inside of the parentheses I'm going to write 4x squared plus 4xy plus y squared. Now, let's take a look what we have inside of the parentheses. Inside of the parentheses we have quadratic trinomial with y, extra variable, in the second term and the third term. But notice that in the third term, y is raised to the second power, okay, which is twice whatever I have in the second term. That's why I can forget about y's for a moment. That's why I'm going to write this problem as 4, and I have 4x squared plus 4x plus 1. Okay, remember, anytime you are going to forget about y squared, there will be always invisible 1 next to it, and anytime you are going to remove y, this invisible 1 becomes visible. I'm going to concentrate right now on the quadratic trinomial. My leading coefficient is different than 1. That's what I'm going to do. I'm going to multiply this leading coefficient by the last term, and I have 4 times 1 is equal 4. The question is, what two numbers multiplied by each other are going to give me 4 and add to each other are going to give me 4? There's 4. There are 2. 2 times 2 gives me 4, and I have 2 plus 2 is equal also 4. That's why I'm going to rewrite this expression as 4, open parenthesis, 4x squared plus 2x plus 2x plus 1. 4. Let's check what we can factorize. The greatest common factor for 4x squared and 2x is 2x. And inside of the parentheses, I'm going to have 2x plus 1 plus whatever left, I'm going to write inside of the parentheses 2x plus 1. Close parenthesis, close parenthesis. I'm going to copy down 4. And the common factor for these two terms is 2x. That's why I'm going to write 2x plus 1. And whatever left, I'm going to write inside of the second pair of the parentheses. Remember, anytime there is no integer, there is always invisible 1. So I'm going to have 2x plus 1 over here also. 2x plus invisible 1, which becomes visible. Okay? Now, so this is the part of my final solution. Remember that at the beginning we removed y's. We have to bring them back. Because there is no y in my first term, I'm not going to have y in my first terms of my binomials. That's why I'm going to write 2x plus 1 times y is going to give me y. 2x plus y. Let's check if this is correct answer. Now, because I have product, okay, inside of this parenthesis, I can remove this parenthesis and I'm going to write this simply as 4 2x plus y times 2x plus y. Okay, next I'm going to use the FOIL rule to verify my final answer. I have 4 and 2x times 2x gives me 4x squared. 2x times y is 2xy. Y times 2x is 2xy. Y times y is y squared. Combine the like terms. 4x squared, 2xy plus 2xy is 4xy plus y squared. Now you have to use the distributive law and simply multiply this 4 by every single term inside of the parentheses. That's why I'm going to have 16x squared plus 16xy plus 4y squared. As you can see, this is the original trinomial, quadratic trinomial. That's why this is the solution to my problem.